What's in a name? Well, as it turns out, a whole lot of confusion. A single word can mean something completely different depending on where you are in the world. So, how do we even begin to make sense of it all? Okay, let's dive right into an example. Take the word robin. If you're in Europe, you're picturing this small flycatcher type bird, but hop over to North America and you're thinking of a much larger bird, part of the thrush family. Same name, two totally different animals. So you can see the problem, right? How is a scientist in London supposed to talk to one in New York about a robin without getting their wires completely crossed? And that brings us to the big question here. If our common, everyday names can get this messy, how on earth do scientists around the globe manage to communicate clearly? How do they collaborate and build on each other's work without all this confusion? The answer is a system. It's called nomenclature. Now, I know, it sounds like a super fancy word, but its job is actually pretty simple. To create a kind of universal language for science. It's all about bringing order to the chaos and making sure everyone everywhere is on the same page. So how does this work in, say, biology? Well, the system they use is called binomial nomenclature. That literally just means two-name naming system. It was made famous by a botanist named Carolus Linnaeus, and his idea was just genius in its simplicity. He said, let's give every single species a unique two-part name in Latin. Okay, so let's go back to our robin problem and see how this fixes it. Using this system, the European robin isn't just a robin anymore. It's Erithacus rubecula, and the American robin, that's Turdus migratorius. And just like that, boom, the confusion is gone. It doesn't matter if you're in Paris, Texas, or Paris, France, that scientific name means exactly the same thing. This whole system really stands on three powerful pillars. First, there's universality. The same name is used worldwide, no matter the local language. Second, uniqueness. Each name belongs to one and only one species. No duplicates. And third, stability. These names don't just change on a whim. There has to be a really compelling scientific reason. And you know, this system applies to everything living, including us. Yeah, you and me. No matter what language you speak, in the world of science, we're all Homo sapiens. It's a name that connects every single one of us. But this idea, this need for clarity, it doesn't just stop at our own planet. Think about it. Astronomers use really similar systems to catalog everything out there in the cosmos, from the tiniest little asteroid to massive exploding stars like supernova 1987A. It's all about creating a universal map of everything we find, no matter where it is. So here's the bottom line. A universal name creates a universal conversation. It's the key that lets thousands of scientists all across the globe, speaking hundreds of different languages, actually work together. It's what turns what could be total chaos into the incredible reality of shared discovery. Hey, if you enjoyed this little explainer and want to see more breakdowns of cool topics like this, do us a favor.